So looking at worksheet 2, lots of trig, a little bit of exponent. So let's just remind ourselves what the derivative rules are. Because I don't want to memorize integration rules. I just want to memorize the derivative rules, and then I can use them in reverse. So the derivative of sine is, what's the derivative of sine? Cosine. And what's the derivative of cosine? Sine. Let's just write them all out, because we'll probably use them all here. So there's sine and cosine. Derivative of tangent, secant squared. Derivative of cotangent, negative cosecant squared. Right? Once you get a few of these, you remember the pattern, and you don't have to memorize all 6 independently. And then lastly, the derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. I also see some exponents on here, so let's remind ourselves what the exponent rule is. It's our favorite rule. My favorite rule. What's the derivative of e to the x?
E to the x.
What about the derivative of 5 to the x, though? If you look down at number 16, you might remember what I'm missing. I mean, it doesn't tell you the answer to this, but it might trigger your brain. The derivative of 5 to the x is
5x times the natural log of 5.
5 to the x times the natural log of 5. Okay, so those are the derivative rules that we, in theory, know. And now we just have to know them so well that we can use them in reverse. Let's see. How about number 6? Let's hopscotch around a little bit here. Number 6, going backwards from cosecant cotangent. Let's see. Well, it looks a lot like the derivative of cosecant, except we're off by a sign. So we can fix that. Negative cosecant of x plus c.
That side of Miss Murray's room makes sense now.
Let's see. Tangent squared plus 1. I don't see a derivative. I don't see a trig function whose derivative is tangent squared.
Yep.
But, pre-cal students, I do remember something about sine squared plus cosine squared equals 1. And so, if I could make this look like tangent squared plus 1, it's Landon calling out the answers back there. If I divided everybody by cosine squared, I would get tangent squared plus 1 equals secant squared.
Okay.
Right? I don't have all 3 of the Pythagorean identities memorized. I have this one memorized, and then I can figure out the others as needed. So tangent squared plus 1 is equal to secant squared.
Let's see.
Wait, hold on. No, tangent squared plus 1 is equal to secant squared.
Oh.
I have not done a calculus thing yet. I've done pre-cal, but I've not done calculus. Now I need to take the antiderivative of secant squared. So we look at the top, and the question is, who has a derivative of secant squared?
Tangent.
Tangent does. And then, yes, plus c at the end.
Are we going to have to rememorize those?
I'm going to say you have to rememorize one of them and know how to get the other 2. Sine squared plus cosine squared is 1. If you want to get the other 2, you either divide by cosine squared or you divide by sine squared. So the other one would be 1 plus cotangent squared equals cosecant squared. But, so you do definitely have to know the first one. I don't memorize the second two because there's too many plus ones and who's paired with who. Like, memorize the first one and then take a minute to figure out the other two. Let's see.
What about number 7?
What about number 7? Find the antiderivative. So it's the same question, they're asking it differently. So what function would have a derivative of cosine? Sine. So that one would be 5 sine of x. What function would have a derivative of sine? Negative cosine. So let's put that as minus 4 cosine of x. And we still need a plus c on there because whatever the constant at the end is would get derived away.
Do we still have to up the, the exponent?
Up the power?
Yeah.
That's only if it's x to some power.
Okay.
So you don't do that with sines and cosines. So this is not going to be like sine squared over 2. The antiderivative of sine is negative cosine. The power rule only works for just x's. Why don't you try 13 and 14? I'm going to press pause. Let you try 13 and 14. So a little bit of algebra first, and then the calculus. And again, this is perfectly okay, but multiple choice, of course, is going to clean it up a little bit. So 14, a little bit of algebra first. I did want to say, if you stop here, this is where things get confusing, because it's like, if you drop that symbol, that means you've done the thing that the symbol is telling you to do, but you haven't done the thing that the symbol is telling you to do. Once in a while, students in the younger grades struggle with that when they're like doing the square root of 9, and it just disappears, and it's still 9. You're like, well, you hadn't taken the square root yet. And I don't think any of y'all would make that mistake. But some of you will make the mistake where you do the same thing here. You rewrite what's in there, but you still got to do this because you haven't used it yet. Until you make use of it, it's still got to be there. All right, so now increase it by 1. So that would get us to 3/4, which means a 4/3 to counter the 3/4. The 6 is still there. So we can clean that up in a minute. Cosecant, cotangent, that's the one that goes with cosecant, but the sign's off, so minus cosecant, and then plus c. And again, perfectly acceptable safe stop. You should safe stop it if you're allowed to, because, 95 times out of 100 you're going to reduce this correctly. Hopefully 100 times out of 100, but once in a while the brain slips and something happens, so don't mess with it. 8, unless you're looking to simplify or multiple choice and you don't have a choice. 8x to the 3/4 minus cosecant x plus c. Again, either one's fine. One's going to be the multiple choice answer.
Could you do number 12?
Yep, we can back up and do number. Oh yeah, secant, sine, cosine. What the heck? You can't go piecemeal. You have to take the antiderivative of the chunk. You can't just go, well, the antiderivative of this, and then this, and then this.
Because I know sine divided by cosine is tangent.
And then there's not a product rule or a quotient rule. So you're kind of stuck. Sine over cosine is tangent. That's true. I don't know if that helps us or not. Sine over cosine, because there's the trouble with trig is there's 100 different ways to combine these things. Sine over cosine is tangent. All right, let's start there. See if that helps. Oh, whoops, that would be tangent, and no, that's right, secant tangent.
What about the secant divided by cosine? Because those two are
You-
multiplied together.
Wait, you paired the cosine with the sine, so
Yeah.
it's not under the cosine as well. You get to put it with one of them, not both of them.
Okay. That's why I asked for help.
So that was the right pairing, because we have to recognize some of these answers and be like, wait a minute, I know that. There is a function whose derivative is secant tangent, and that's secant. So secant x plus c. But you could have gone down the wrong path and said secant is 1 over cosine and had sine over cosine squared, and that wouldn't be wrong, but now you're off on the wrong track. How about number 16?
We would do that at the top.
We kind of did that at the top.
We did divide to the x at the top.
Yeah, we did the derivative. This is asking for the antiderivative. So I know 5 to the x becomes 5 to the x. That's the easy part. But all my answers have 5 to the x in them. Oh, except for this 5 to the x plus 1. That's trying to use the power rule where it's not allowed. Increase the power by 1, divide by the new power. That not there. So where does the natural log of 5 go?
We're about to find out.
I got to do something with it, so it's not a. Okay.
But b is the derivative. So
Yeah, when you take a derivative, you multiply by natural log 5.
So you would divide by the antiderivative?
And so if you're going backwards, if you're derivatizing, taking an derivative, then you're going to divide by natural log of 5.
Logic.
Derivative, antiderivative are backwards. They undo each other. So multiply and divide work backwards as well. Again, that's why we want you to know the forward rules well enough. That way you're not memorizing 2 sets of rules. You just really know the forward rules well, and then you can figure it out going backwards. That's the hope. Let's see. Oh, we got some weird stuff going on in the back here.
Yeah. It's fun.
Just trying to mess you up with e's and pi's. I like 17. That's a good question. So the antiderivative of e to the x
Well, it has to have an e times x, right?
has got to just be e to the x. And there's no extra stuff on that, so that's why we like e to the x. Derivative, antiderivative, multiple derivatives, multiple it doesn't matter. It's always just e to the x. But what about the antiderivative of e?
E times x?
Yeah, because e is just a constant. Right? We don't like e, but e is just 2.7. So the antiderivative of 2.7 would be 2.7x. So plus ex plus c. Yeah, just when in doubt, don't forget e is a constant. Pi is a constant. Let's see, e to the x plus ex plus c. Answer choice E. $18. Some wild answer choices there.
I think it's b.
Let's see. You think it's b, because the antiderivative of 2 to the x, let's go one piece at a time here, is 2 to the x. When we take a derivative, we multiply, so when we antiderivative will divide by natural log of 2. Okay, so I'm looking at my answer choices. A uses the power rule, but that's not the right use of the power rule.
It has to be divided by the natural log.
Needs to be divided by natural log of 2. So B and C are looking good. What's e to the pi?
E to the pi times x.
Yeah, it's a constant. Whatever it is, that's a weird number, but it's just a constant sitting there. So I can antiderivative a constant and get e to the pi x. And then plus c. So answer choice B.
Please tell me 20 was just a formatting mistake.
20, well, yeah, that negative cotangent should not be up there.
Not in the problem where the dx is on top.
No, that's the same as if the dx is at the end.
Oh, okay.
Right? That's the same as 1 over sine squared x times dx. That means the same thing. I don't really like 1 over sine squared. What's this? How could I not do calculus yet? What's 1 over sine squared? What's another way to say that? Cosecant squared. And then hopefully your brain, an alarm bell goes off of, wait a minute, that looks familiar.
Cotangent.
There's somebody whose derivative is cosecant squared or almost cosecant squared. Let's see, tangent goes to secant squared, so cotangent goes to negative. So I wish they'd had a positive cotangent as one of your answer choices. The rest of those are trying to use the power rule in some sort of weird way. Alright, so that's enough for me to have done. I'll let you work the rest. We have a quiz on Wednesday. It's 8 questions, very similar to those. Has some trig, lots of power rules, no exponents, one differential equation where you have to go backwards, to find C, and the rest is really similar to worksheets 1 and 2.